Okay, as for example, I have shown here, suppose the visible wavelength lambda 1 is absorbed by the iodine molecule, okay, then iodine molecule goes from vibrational level nu double is equal to 0 to nu dash is equal to 1, okay, and lambda 1 wavelength is absorbed by the iodine molecule, that will appear as a dark band in the transmission spectrum, okay. Now lambda 2 wavelength is absorbed by the iodine molecule, okay, then molecule goes from nu double dash to 0 level to nu dash is equal to 2 level, okay, and that will be giving the second dark line in the spectrum, okay, and lambda 3 wavelength of the visible light is absorbed by the iodine molecule, and then iodine molecule is excited from nu double dash to 0 to nu dash is equal to 3, that will be giving the third dark line in the spectrum of transmitted light, right, okay. So here we will get the spectrum. आपको 3 रीडिंग लेना है स्पेक्ट्रम में. You have to take the reading of first dark band. आपको रेड रीजन में डार्क बैंड मिलेंगे, येलो रीजन में डार्क बैंड, ग्रीन रीजन में डार्क बैंड मिलेंगे. तो रेड रीजन में जो भी फर्स्ट डार्क मिलता है उसका रीडिंग इन द रेड वन. सो यू हैव टू टेक पुट द क्रॉस वायर ऑन द फर्स्ट डार्क बैंड ऑफ द रेड रीजन, उसको बोलते हैं रेड वन. उसका रीडिंग स्पेक्ट्रोमीटर रीडिंग लेना है इधर से, रेड लेवल से. देन सेट द क्रॉस वायर, पुट द क्रॉस वायर ऑन द फिफ्थ डार्क बैंड इन द रेड रीजन, फिफ्थ डार्क बैंड इन द रेड रीजन. रेड 5 का रीडिंग लेना है स्पेक्ट्रोमीटर में, ओके. एंड द लास्ट बैंड ऑफ ग्रीन रीजन, दैट इज उसको बोलते हैं ग्रीन कंटिन्यूम. ग्रीन कंटिन्यूम का रीडिंग लेना है. ग्रीन कंटिन्यूम मींस दैट इज द लास्ट बैंड ऑफ ग्रीन रीजन. उसके बाद आपको स्पेक्ट्रम नहीं मिलेगा, आपको यू विल गेट अ कंटिन्यूअस स्पेक्ट्रम. तो आपको 3 रीडिंग लेना है. फर्स्ट स्पेक्ट्रोमीटर रीडिंग ऑफ फर्स्ट डार्क बैंड in the red region, that is called red 1 reading. Spectrometer reading of fifth dark band in the red region, that is called red 5, and the last band of the green region, that is called green continuum का reading लेना है, right, okay. उसके बाद you have to take a straight reading, right, and you have to find the diffraction angle of red 1 with the straight reading. That is called theta r1. Theta r1 is the angle at which we get the red 1 line at with the straight reading. Then you can find the diffraction angle theta r5, that is the diffraction angle of red 5 with the straight reading, and then you find the diffraction angle theta green continuum with the straight reading. तो straight reading के साथ आपको red 1 लाइन मिलती है theta r1 एंगल पे, red 5 लाइन मिलती है theta r5 एंगल पे, और green continuum मिलता है theta green एंगल पे, right, okay. Now I will put this synopsis and observations of red 1, red 5 and green continuum on your WhatsApp group, okay, and your assignment is to calculate dissociation energy of iodine molecule, right. The dissociation energy of iodine molecule का equation मैंने दिया SC upon 1.6 times 19 1 upon lambda green minus 1 upon lambda red 1, right, okay. H you know Planck constant, उसकी वैल्यू 6.625 10 to 34 joule into second. C is the velocity of light 3 10 to 8 meter per second, okay. So dissociation energy of iodine molecule E nu is SC upon 1.6 times 19 1 upon lambda green minus 1 upon lambda red 1. lambda G के lambda red 1 क्या है, okay. Lambda red 1 is the wavelength of red 1, okay, which is absorbed by the iodine molecule. Lambda alpha is the wavelength of red 5 line which is absorbed by the iodine molecule. Lambda G is the wavelength corresponding to the green continuum, right. I have given you the equation of wavelength lambda 1 upon nn into sin theta, और lambda is equal to E sin theta. इसमें E क्या है, E is the grating element. What is the equation of grating element? 2.54 10 to minus 2 upon n. N is the number of lines per meter in the grating, okay. How many lines are there per meter in the grating? 15,000, right. So I have given you the equation of grating element E is 2.54 times minus 2 upon number of lines per meter on the grating is 15,000. So you know the grating element E, you know the angle of red 1, diffraction angle of red 1, that is theta r1. You can calculate the wavelength of red 1, okay. You know theta r5, okay. Using this equation lambda degree sin theta, you can calculate lambda r5. You know the angle of green continuum, diffraction angle of green continuum, you can calculate the wavelength corresponding to green continuum, lambda g, right, okay. So substituting the value of lambda of wavelength of green continuum and wavelength lambda of red 1, you can calculate the dissociation energy of the iodine molecule. And second quantity you have to find out, that is the force constant of iodine molecule. The equation of force constant of iodine molecule is 4 pi square mu C into delta nu bar square. 4 pi square mu C into delta nu bar square, Newton per meter. Well, delta nu bar is the average of wave number. Nu 5 is the wave number of red 5. Okay, what is the wave number? It is the inverse of wavelength. Lambda nu 1 is the wavelength of wave number of red 1 divided by 5, right. So using these two equation, you can calculate the dissociation energy of iodine molecule and force constant of the iodine molecule. I will give you the spectrometer reading of red 1, okay, spectrometer reading of red 5 and spectrometer reading of green continuum. Okay, I will also give the straight reading. You can find out the diffraction angle of red 1, that is theta 1. You can calculate the diffraction angle of red 5, calculate the diffraction angle of green continuum. Okay, and from these two equations, find out the dissociation energy of hydrogen molecule and force quotient of hydrogen molecule. Mu is the reduced mass of hydrogen molecule. Mu is the reduced mass of hydrogen molecule. C you know 3 × 10⁸ meter per second, and delta nu bar का equation में दिया nu 5, that is 1 upon lambda 5, nu 1, that is 1 upon lambda red 1 upon 5. Okay, now here if lambda r is the wavelength of first dark band in the red region, then E is equal to, you can write Sc upon lambda. You know the equation of energy is Sc upon lambda. So if lambda r is the wavelength of first dark band in the red region, then E is equal to Sc upon lambda. If the wavelength corresponding to the continuum is lambda green, then the energy absorbed in this excitation will be Sc upon lambda green. So for red 1, energy is Sc upon lambda r. Energy absorbed for red 1 is Sc upon lambda r. Energy absorbed for green continuum is Sc upon lambda g. So dissociation energy of hydrogen molecule is Sc 1 upon lambda green minus 1 upon lambda r. Okay, electron volt में से आपको जूल में कन्वर्ट करना है, तो you divide it by 1.6 × 19. Okay, so I will give you, put this synopsis on the WhatsApp group. Okay, I will also give you this data, spectrometer reading of red 1, red 5 and green continuum. You have to calculate these angles, wavelengths and two quantities, dissociation energy of the iodine molecule and force quotient of the iodine molecule. Thank you so much. We stop here.